Hello, everyone. Welcome to Loctite webinar. My name is Ken Du, Global Market Development Director.
Hi, everyone. My name is Eric Wu, Sales Rep of Henkel Taiwan.
Thanks for joining today's webinar. Before we get started, some housekeeping notes. The console can be removed or resized, and there are widgets on the bottom of the screen. You can see webcam, slides, and Q&A. We are going to do a Q&A section at the end of the webinar. So if you have any question, please send to us. Clicking on the resource button, you will find today's slides, literature, and YouTube link to watch our previous webinars. And we really want to hear from you and to know what we can improve next time. So please let us know what you think by answering the question, clicking on the survey. If you want to have a local contact person and the engineer to help you, also please send me an email and we will contact you soon. Okay, Eric.
Yes.
So tell us what we are going to do for the next 30 minutes.
We were talking about the several common joint methods and run the dynamic impact test on the specimen to see which specimen can last to the end of this test today.
Sounds like we'll have a lot of fun today. So what is the common joint methods you mentioned about?
That would be welding and the mechanical fastener. That would be widely used by the industry for long.
Then when the designers, they are designing their products, what are the requirements they think about the structural bonding?
So the structural bonding, the requirement is not limited to the functionality, but also has to be the compact, lightweight, and strong enough to withstand the dynamic loading applied.
Okay, so which one is the most critical one?
I would say dynamic loading.
Well, what is it?
The dynamic loading will be including the vibration, repeated cycle loading, impact, and etc. Let me start from the video on my right. You see, this is an engineer. They put the specimen on the universal tensile tester. The tensile tester apply the tensile load on the end of this specimen to break the joint. And then the data we collected from here is a static strength. But most of the structure, the load applied is not static one. Let me go to the next video. This sports vehicle allowing the driver to twisting the powertrain to push the engine to the limit to show off his technique on the ground. This is a snow motor. The challenge for the snow motor is the impact on the ground after the jump. This is a wind blade for the wind power station. We are doing the simulation to simulate the load applied to the wind blade during its service period. The service period of this wind blade, the video is not moving. Okay, it works now. The service period for the wind blade can be as long as 1 decade or 2 decades. I take these 3 videos to answer Kendu's question. The dynamic loading is of the most critical one, and then has to be the critical success factor for a structural design.
Okay, so we're using this one today, right?
Yes, we are going to use the jig to test the impact loading of the specimen prepared today.
Good. So let's proceed to the most exciting part. Then when you do the test, how can we tell if it survived or not?
The criteria to decide whether it's the pass or fail today is very simple. As long as the assembly will break apart into 2 pieces, then we will define it as a fail. If it's still intact together, we will regard it as a pass.
Okay, good. Then that's simple. So let's start.
So before we start, let me explain. The specimen we use today is carbon steel. This is a carbon steel A36 or equivalent to GIS 400A series steel. We will start from the specimen joined by welding. Please give me a snapshot on the welding the specimen here. So you see that the joint on my hand, and you can see from the video on the screen, we have put the thick weld on each side. So totally 4 spot weld on this jig, on this specimen, with an overlap of 3 centimeters. Then we will put this specimen under the tensile tester, impact tester. The impact tester is modified from the Loctite internal standard. We will convert the potential energy of the pendulum from a predefined swing angle to an impact energy at the joint. So the impact resistance is measured by energy. It's approximately about 10 joule. So let's start from the test now.
Okay.
This is a joint by the welding.
It's still perfect.
Still intact. So we can proceed the similar test to the joint by the assembly method. The second one is the joint done by the mechanical fastener. As you can see, we have the 2 M4 fastener to do the assembly. Then we put onto the impact tester to see the impact strength of the assembly. Can you tell us what have you seen from the specimen?
I think it's still good, but I can see that the placement between the 2 substrates, like this.
Yes, but still pass the pass criteria because the 2 parts still stay together. So we keep it in the pass area. Then we will proceed to the joint done by the chemical way. The first one we want to demonstrate is the assembly done by standard acrylic or standard instant adhesive. This assembly, if we move to the static tensile tester, it will take about more than 1 ton to break this joint. But today we want to test the dynamic loading capacity. So we will put it onto the impact tester to see how strong the joint will be. Oh, sorry, I have to put on this one. It breaks immediately, but anyhow, we still want to have an inspection by Ken to see how is the failure mode here.
Yeah, it's not surprised. It's separated. And you can see the both sides, they have the residues.
So this is a very typical cohesive failure of the joint. So adhesive is very strong at static loading, but not strong on the dynamic loading. So we have to move it to the failed area. This is the standard acrylic. Then the next specimen is also done by acrylic, but this is the black colored acrylic. So you can see some excessive glue on the edge is the black color. Let's put onto the tester to see how is the response, how is the performance.
Wow, amazing.
Yes, pretty different from the standard acrylic.
Yeah, it's pretty good, although it's a little bit distortion, but basically it's good. So the black color means the better CA?
Not really. When I say black color, it's because we put in the black colored rubber into the formulation to let the rubber absorb the impact energy.
Okay.
But sometimes we can also add in the white color, make the color white. But anyhow, the deformation is very minor, so we might not be able to see from the video, but let's proceed to the next candidate. This is a structure acrylic. The structure acrylic we use widely on the high performance magnetic bonding for many years. And this can also be used on the structural bonding. Let's move on to the impact test to see how it performs. Okay.
Also good. Although a little bit distortion as well, similar to the toughened CA. So when you say structural acrylic, I know what is acrylic. Then what is the difference between these two?
Because acrylic resin is very brittle, it's not the right candidate for structural bonding because it can't resist to the impact loading. We modify the formulation by adding some polyurethane resin into the backbone of acrylic resin to make it more robust to resist the dynamic or impact loading.
Okay.
Then we come to the last candidate. This is a structural epoxy. We have been used this widely on the composite material for aviation or sports goods or sports bike. Those kind of the product, it needs some very strong dynamic loading capacity. So we mount it onto the impact tester to see how it performs. Or it bounce back.
It's perfect. So even a little bit better than structural acrylic.
Okay. Now we have completed the first round of tests, and then the standard CA has been out of this game. Now we have to speed up the test by increase the impact energy. To increase the impact energy is very simple. The way I did is that I'm trying to increase the swing angle from 90 to 180 degrees, and then double the impact energy to the joint. Let's come back to the first candidate, the welding specimen. This one on my hand is just showing to us is a 4 spot weld on this joint.
Wow.
Well, believe this one has to be out of this game.
Yeah. Yeah, I thought the welding should be strong enough, but actually it broke. So it separated completely.
Yes. But later on, we can have a very close look to the failure, the specimen. All the joint break from the welding place. That means that this has a very serious stress concentration on welding joint. So this is things most of the structural engineers do not want to see. But let's move to the failed area. But anyhow, today I also prepared to upgrade the joint. This one, I put additional spot welding joint, make it a 6 spot welding joint. Can you give me a snapshot here? So as you can see from the screen, there are 3 spots on each side, totally 6 spot welding joint on the specimen. So let's repeat the test here. Oh, sorry, has to be 180.
So even you increase the joints number from 4 to 6 and still fail. So do you have other specimens to increase the joints as well?
We prepared the very last one because the overlap is only 3 centimeters. So I think it can maximize the accommodated. One more, the spot weld joint here.
So now we increase to 8 joints.
Yes, totally. 8 spot weld joint on this assembly. Let's see how it performs.
Wow. So now even we increase the welding joints from 4 to 6 and even to 8 joints, still fail. Okay.
Now we go to the traditional assembly method, mechanical fastener. That's the one just survived through the first round of tests. So we have to get into the second round.
Not surprised. It's still there, but you can see a very serious displacement between the 2 substrates. So I guess these 2 joints suffer a lot of loading, right?
Yes. As you can see that the displacement at the joint area, if this mechanical fastener is used for the whole structure, so you can imagine the whole structure will have a serious displacement. So it cannot perform the right functionality. But based on today's the judge criteria, I will still keep it in the pass area. So we next proceed to the adhesive, the assembly. This assembly, remember that this is a black color sand acrylic. We adding the black color rubber into the formulation to increase the loading capacity. But I'm not sure if today it can pass this very critical impact test.
Wow, it's a very strong CA. I'm not sure if you can see it, but it's a little bit separation between the two substrate only, but most of the parts are still stick together.
Yes. If you can notice about the deformation of the substrate, which means that stress start to distribute evenly to the whole structure. It's not concentrated on the joint only. So not like the failure criteria or failure mode, we have seen that on the joint done by the welding. This is the structure acrylic. We modify the accuracy by adding the polyurethane resin into the backbone. So see how it performs here.
Wow. I think it's still perfect. You can see the bonding area is totally fine. It's nothing happened. But the other parts of the substrate itself distortion a lot.
Okay. Let's move to the last one, structure epoxy. Before going to the second round, looks perfect intact.
Yeah, also very good. Survived, perfect. So Eric, I have a question here. Why the structure accurate, you see the distortion of the substrate? How can we explain that?
The distortion to the substrate, you can see that, which means that the energy has been absorbed by the structure other than the joint itself. From the structure point of view, this is a very good failure mode because the whole structure can absorb the impact loading instead of the joint will take the full impact energy. So it enhance the robust structure integrity of the whole structure design. So that's what engineers really want to see, this one.
So we could say the bonding area itself is perfect. It's a no impact, and then the other side is the substrate itself fail.
Yes.
Not the bonding area.
Yes.
Okay, very good.
So that comes to the end of the impact test demonstration today. Hope this can give you some inspiration. I'm going to pass the time to Ken to give us some summary of today's test.
Okay, so we summarize some key learnings today. The number one, mechanical traditional joints are not always the best solutions for structural bonding. You can see from the test, we increased the welding from 4 to 6 to 8, and it still failed. Number two, if you some of the adhesive, specially designed for structure, that they can even perform much better than the mechanical bonding, such as toughen CA, structural acrylic, structural epoxy. Number three, you might need an expert to help you select the right product for your design, and we are the experts. All right, so thanks for joining today's webinar. Now is the Q&A time. Let's see what question we have right now. Okay, so I have a question for Eric.
Oh.
Which adhesive is the most recommended one?
Oh, this question I can't answer in the webinar. just because the substrate we use today is carbon steel. If you are using the composite substrate, if you are going to bonding the aluminum alloy, you will get a very similar test result like we did now. But if you are using some other substrate like engineering plastic or some other the alloy, I'd rather suggest you can reach out the local the application engineer to give you the best advice.
Okay. The next one, the shelf life of the product.
Oh. For the material we offered here, except for some very critical material, most of the material has a shelf life of about 24 months. But the only exception is the acrylic we recommend here. The CA we offer is a shelf life approximately 18 months from the date of manufacture.
Okay. The last one, do you have the product IDH of acrylic product?
I can't remember this detailed information, but you feel free to reach out the local application engineer to get this information. The product on the bench here is for decoration only. We have a lot more offering other than the things sitting on the table to meet your expectation, not only the performance, but also the pricing, but also the production efficiency.
Okay, good. So thanks for all the good questions. We are about to close the webinar right now. If you still have more questions, then please send email to us. And we also can schedule a live survey with you and to see if there's any potential possibility to reduce the cost and improve the reliability for your assembly line. And we also can help you to organize an in-plant seminar that can help you how can better use adhesive solution. Thanks again for joining today's webinar. We hope to see you next time. Bye-bye.
Bye-bye.